I've received some questions about the mechanical fuel pumps that I use for my carb conversions. A diaphragm operated mechanical fuel pump is very different from an electrically operated rotary vane fuel pump. And I think there are just some people that did not grow up with carburation and are kind of confused or unsure of exactly how a diaphragm operated fuel pump works. So these are the two fuel pumps that I use with my carb conversions. This is a Sofabex's fuel pump made in France, and this is a BCD Corona fuel pump made in Italy. And as you can see, they're virtually identical to each other. And with the exception of the check valves inside, they have two different styles of check valves, but other than that, the innards of these two pumps are virtually identical. And the mode of operation, the way they actually move the fuel, is 100% identical. So I use these Sofabex's pumps with my 5-speed conversions, and I'm using these BCD Corona pumps now with my automatic conversions because, as you can see, the BCD Corona pump is just a little bit lower. This is where it mates up to the cylinder head, and so from the cylinder head to the top of the pump is just a little bit lower with the BCD Corona. And the governor cable, the automatic transmission shift point cable, passes directly over the top of the fuel pump. So you have a little more clearance with the BCD Corona pumps than you do with the Sofabex's pumps. So I'm using these for automatics and these for 5-speeds. But before I show you the innards of the pumps, let me put an animation up that will show the operating principle of a diaphragm operated mechanical fuel pump. This animation that I found online does a pretty good job of demonstrating how a diaphragm operated mechanical fuel pump works. As you can see, there's 3 major components. You have a diaphragm moving up and down, and then 2 check valves, one on the inlet side and one on the outlet side. And notice that the 2 check valves are pointed in the same direction. So the fuel can only move in one direction. It can't move backwards, it can only move forwards. And what happens is the diaphragm moves downwards, which creates suction. The inlet check valve opens, the outlet check valve closes, and fuel is sucked from the gas tank into the chamber where the diaphragm is. And then the diaphragm moves up, the inlet check valve closes, the outlet check valve opens, and the fuel gets pushed out to the carburetor. And then the cycle repeats. And that rod that you see moving the diaphragm up and down on a PRV, that is activated by a lobe on the passenger side camshaft. Looks just like a lobe that would open or close intake or exhaust valve. But in this instance, rather than pressing on a valve, it's pressing on a rod that will operate the diaphragm. Let me clarify something that is a little misleading in that animation. And this has gotten owners into trouble in the past. when they're trying to mechanically, or manually I should say, operate their fuel pumps in their hand. That animation makes it look like the rod that's being pressed by the lobe on the camshaft is what's moving the diaphragm up and down. Well, on these particular fuel pumps at least, that is incorrect. Okay, the rod is indeed part of the equation, but what actually moves the diaphragm up and down is this spring here. The rod is basically downward force. It doesn't have really anything to do with the upward force other than limiting how far this spring can press up on the diaphragm. And you can see how far this rod goes into the fitting that attaches it to the diaphragm. It never moves this far in normal operation. Okay, same with the BCD Corona. As you can see, it's basically the same setup. This is the spring that is going to push up on the diaphragm, and notice how far this rod can move. It's at least 1/4 inch, maybe more. But it never moves that far in normal operation. In normal operation, it's just kind of wiggling around here down maybe 1/8 inch at most if you're lucky. Because what this rod does is it limits how far this spring can push up on the diaphragm. And what has happened is I've had owners that have been operating their pumps by hand, and they've been pushing this rod. Look at how far this rod, you can push it all the way to the top. And then they're doing this up at the top, where the diaphragm is shoved up against the check valves. And it can't work. And it's definitely not moving because you've compressed that internal spring, too far. In normal operation, it's just going to be kind of doing this. Maybe 1/8 inch if you're lucky. If you have any question, just listen for the noises that the check valves will make. This is a Sofabex pump, and I'll show you in just a minute that it has mechanical check valves. So you can hear those mechanical valves opening and closing. And look at how little I'm moving that connecting rod. And the check valves in a BCD Corona are different. They're an umbrella style, rubber umbrella style. So they don't make a mechanical noise, but they make a whooshing noise. Let me hold it next to the microphone and maybe you can pick up the whooshing noise. So hopefully you're able to hear it going. So if you want to operate the pump manually, and I'll show you in just a minute how you can do that, do not push this connecting rod all the way to the limits of its upward travel, because it never moves like that in normal operation, and it won't work like that. It's only going to work if it's moving like 1/8 inch down here. So I just wanted to clarify that real quick. Let me show you the check valves, the actual meat and potatoes of the operation. This is what you'll see if you remove the ring of fasteners that hold the valve body to the diaphragm base. And so this is a BCD Corona valve body, diaphragm base, Sofabex valve body and diaphragm base. And it should become readily apparent when you look at them that they have two totally different styles of check valves. The Sofabex check valves are an actual mechanical valve. It has this little cage here, and right in the center, if you look right in there, you'll see a little spring, and then there's a rubber seal. And so this is like an actual mechanical device that is opening and closing. The BCD Corona uses what I call an umbrella seal, like a rubber umbrella seal. This is just like the seal on your accelerator pump. Looks just like it, works just like it. It's 100% identical. So it's a totally different check valve, and that's why they make two totally different noises. But operationally, they're identical. They both work 100% the same way. You'll notice that they're both pointed in the same direction. They're both pointed towards the outlet. This is the outlet side here, so this is the inlet. There's the outlet. So fuel comes in, it gets pulled down into this chamber underneath. Then the diaphragm moves up, pushes the fuel through that check valve. I have a plug here, and pushes it to the outlet, which is then connected to the metal fuel line. So these are the check valves that actually make the pump do its thing based upon, the diaphragm creating suction and then pushing the fuel out to the carburetor. I've had owners ask me, what is the best way to verify that my pump is working? And obviously the easiest way is to just pop the top off the carburetor and look inside. If there's fuel in the bowl, your pump is working. But if you want to, you can take the pump off the car and operate it manually and see if fuel squirts out. I recommend using gasoline and not water. We have enough problems with water in our ethanol fuel as it is. No sense introducing any more water into the fuel system than is necessary. But just put a hose into your gas can, just like the fuel line in the car. Beware, fuel is going to come squirting out of here, so watch where you point the outlet. And then you can just operate the pump by hand, and you can see fuel is just squirting out of my pump. And if you find this piston too hard to push by hand, you can put the pump on the ground and just operate the pump on the ground like that. But if you work the pump manually, that's how the fuel comes out. Let me say one last thing about the portion of the fuel system that is under pressure versus the portion of the fuel system that is under suction. This caused a little bit of mischief for an owner I was helping. He had a bad accumulator, and he was sucking air through the bad accumulator rather than fuel from the tank. Us carb guys, we repurpose the old K-Jet return line as a front to rear fuel line. This is the old K-Jet return line going to my pump, and there's a T in that fuel line that used to go to the back of the accumulator. And I provide a block off plug and a little piece of hose that you can use to cap off that T to ensure that you don't suck air. But if you don't put that plug in, and if your accumulator is bad, because air is lighter than liquid, the pump will end up sucking air rather than sucking fuel from the tank. So it's imperative that you bare minimum have an intact accumulator that won't let any air through it. And the best thing to do is to use that plug that I provide. That's why I provide it, is so that way you can cap off that T, and it'd be almost like that T wasn't there. And then you're guaranteed to pull fuel from the tank rather than air from the bad accumulator. But let me pull out the spark plug wires just to make it a little bit easier to see. So here's my fuel pump. This is coming from the old K-Jet return line. It's now a front to rear fuel line. It goes into the fuel pump, and then this is the metal fuel line that goes over to the filter and then the carburetor. And this metal fuel line from here to here, that is the only part of the fuel system that is under pressure. Okay? There is no pressure between the tank and the pump. There is suction between the tank and the pump. Okay? So any compromise between your fuel tank and the fuel pump, you will not push fuel out of the fuel system. You will suck outside air into the fuel system. And because air is lighter than liquid, I guarantee that's what's going to happen. If you have any kind of a compromise, you'll end up sucking air. So your front to rear fuel line has to be airtight. And then this metal fuel line here, this is the only part under pressure. And it's only about 4 to 6 psi maximum. It's not a lot of pressure. As you saw when I was moving the fuel manually through a pump, it just comes out in spurts. It just goes. So if you ever have a leak in this fuel line, it's not going to come shooting out, it'll come dripping out, which is kind of nice. K-Jet, of course, operates at like 75 psi, so any leak in the K-Jet system, you get a spray of fuel that just comes out under great pressure. More than household water pressure. Household water pressure is about 40 to 50 psi. So, just so there's no misunderstanding, this is the fuel pump right here. This is coming from the old K-Jet return line into the pump. This is under suction. This is the metal fuel line that is under pressure that then goes to the fuel filter and the carburetor.